Some conversions are not pretty integer conversions. Some conversions have ugly decimals in them. What is true of all these conversions? Why do you think these things have ugly decimals in them?
Oh, because customary is like
Say again?
like customary system has like really weird numbers and stuff.
No. Again, compare it to these conversions. These conversions are nice and integery. Okay, 12 inches to 1 foot. But the centimeters to inch is an ugly conversion. Why is that? Harry, what do you think?
Because like when you're within one system, the units were designed to like stack up in logical ways with each other, but converting between systems is kind of just arbitrary lengths.
Correct. Right. These are conversions. Write this down. Conversions between systems are ugly. Okay. If you have to convert between the inch and the centimeter, between the mile and the meter, between metric and English, they don't match each other very well. Are you feeling aggrieved, Alex? You feel like that's what you're saying?
He said that. And you were like, no.
I didn't. You said something like customers. I was like,
Like customary system. That's what we use.
the customary system?
That's what it's called, isn't it?
I thought it was the
Imperial system. Actually, I thought metric is standard imperial.
So, sorry for the explanation. If you're going between two different length unit systems, the numbers are not pretty. Let's talk about one of the prettiest aspects of the metric or system international. Okay, is that if I take 1 centimeter and cube it, what does that become?
1 liter.
1 milliliter. Okay, if I fill 1 milliliter with water, what does that become? 1 gram. That's where the gram came from. Okay, was exactly 1 milliliter full of water. The numbers on the periodic table. Remember our old friend, the periodic table? We haven't looked at it in a month. The numbers on the periodic table. This number up here, the 7, tells us the what?
Number of protons.
Number of protons. The 14.0067 tells us the what?
Number of protons plus neutrons given isotopes.
The mass. Okay, this is giving us the mass. What is that unit of mass in? It happens to be in something called AMU, or atomic mass units. Where did it come from? They took carbon-12 and divided its weight by 12, and that's what they came up with. It is 1 atomic mass unit. Write this down. 1/12 of a carbon-12. Carbon-12 is like one isotope of it. It's made of 6 protons and 6 neutrons. If you divide that by 12, that's essentially what an average of a proton and neutron would be. And so therefore, that's what they use as the atomic mass unit stuff. This is a really small amount of mass. This doesn't weigh very much at all. Okay? Guess how many atomic mass units it takes to make 1 gram?
A mole?
A mole. That's where the mole number that we used in class the other day comes from. Is if you take the atomic mass units and you have 6.022 times 10 to the 23rd, and it's actually worse than that, it's 6.022174, blah, blah, blah. It's a weird, ugly decimally number because it's converting between 2 different systems. Right? That's what it's doing. That's what it is, why it is the number that it is. Yo.
Do all like protons weigh the same?
As far as we know, my understanding is. 1 AMU, that number on the periodic table, times 1 mole equals 1 gram. If I want to solve that for the AMU, if I want to get the AMU by itself, what do I have to do to both sides? Divide by 1 mole. So another name for the AMU, another name that people use for the unit on the periodic table, is they will say the AMU is the gram per mole. Which is why today's notes are called divide by grams per mole. Because grams per mole turns out to be a key unit. And again, when a chemist glances at the periodic table, that's the unit they see. They see, oh, if I have a mole of strontium, it's going to weigh 87.62. If I have that size chunk, again, like the Baker stuff comes in a dozen, the Dunkin' Donuts boxes for a dozen of them, that's going to be the grams are going to match the number on the periodic table. If I have 1 mole of carbon atoms, how much is that going to weigh?
1 gram.
Nope.
12.01.
Yep. 1 mole of carbon atoms would weigh 12.011. And generally, I only go like 2 past the decimal. They're going to hate dragging around extra sig figs. It's going to weigh that many grams.
Is that the number for the atomic mass?
Yes.
1 mole is just one periodic.
Yes. That is what the periodic table is calibrated in, is in mole-sized chunks. Okay? If I have 2 moles of carbon atoms, how much is that going to weigh?
24.02.
24.02 grams. Okay? The number on the periodic table times the number of moles I have is how many grams it's going to be. Okay? 1 mole of nitrogen atom. Somebody in the second row of the classroom, tell me what 1 mole of nitrogen atom is going to weigh. Gene?
14.007.
14, let's just go 0.00 grams. Somebody in the front row, tell me what 2 moles of nitrogen atoms is going to weigh. 28 grams. Solomon, Christian,
We has come like 14.00 gram.
where did that come from?
Yeah.
The periodic table. Look at the periodic table on your desk there. Nitrogen is element number 7. Look at the weight down at the bottom of the box.
14.01.
Is it 14.01? Okay, 0.007.
You round up.
All right, round up. Good, 14.01.
Ah,
28.02. Yo, Catherine.
But if it's 1 mole's 1 unit of measurement, why is it changing like that in chunks? Like, why isn't it a certain amount of grams? Like, why couldn't 1 mole equal 14 grams while it also equals 12 grams?
If I get a dozen bagels, that's going to have a certain amount of calories. If I get a dozen delicious maple frosted donuts, that's going to have a different amount of calories. Even though it's still 12 of them, each one of them contains a different amount of calories. Even though it's a mole of nitrogens, each nitrogen atom weighs a different amount than each carbon atom does. And so therefore, having a dozen of these or having a mole of these comes out to being a different total mass.
It's like having a bowl of air equals sodium and lead,
Yeah.
same size.
I mean, this instead of size, it's number of them. If I have, 20 cars versus 20 mice, they're going to weigh different things. There's still 20 of them, but they have different masses because each one of them is a different mass. Let's deal with our calculators now. Take out your calculators. 3.5 moles of nitrogen. How much would 3.5 moles of nitrogen weigh?
It's not the question.
Oh, of carbon, as it clearly says here.
It's like 42.035.
Alright, 42.0, I'll say 4 grams. Can I get an amen?
Amen.
Okay. 2.7 moles of nitrogen. 2.7 moles of nitrogen. By the way, if you don't have a periodic table on your desk, looks like Sasha's got 2. I've got 1 up here. You should, have 1 within arm's reach. We're going to be using them a lot. Trying to get for the pencil sharpener. It's now over here on this tan thing.
No, I'm looking for the stupid noise.
Just the
In
light.
this general area, but
Does that make it stop? Oh. Okay. 2.7 moles of nitrogen. Somebody raise their hand and tell me what that would weigh.
37.827.
37.827. So we have to round up maybe 32.83 grams. All good? Ready to take it up a notch? We don't need this one. If you guys have got it, we'll go to something else. Let's go the other way. If I have 57 grams of carbon, how many moles do I have? What am I going to do? Divide by the time mass, or divide by grams per mole. We do this so much in chemistry. That's why I pound the desk, because it's like this drumbeat of chemistry. Okay, the chemistry ship is coming. People are divided by grams per mole. Like this is just what we do constantly. We're constantly getting stuff in lab, measuring a pile of stuff. How much do we have of it? How many atoms are actually in there? This is our path to doing that. Divide by grams per mole. Okay, so 57 for carbon, we're going to divide it by 12.01 grams per mole. And we're going to get 4.75 moles. Not quite. What's wrong with that answer?
Same thing.
4.8 moles. If we had 2 in our measurement, we're going to have that there. So if I have a pile with 57 grams of iron in it, that's got 4.8 moles of chemical that could potentially react. And there's an actual number of bits in there. Go with iron. Iron is element 26. Iron is element 26 in the middle of the transition metals.
Why we don't divide by like 6.02 test to
That was yesterday's test 2 days ago. You're living in the past, Solomon. Come, the future. This is what we're doing. Because this, I'm not asking you how many atoms are in here yet. I will do that in a sec. I'm saying how many moles are in here. And so we're converting grams into moles. Okay, so the atomic weight of iron is 55.85 grams per mole. So 57 is going to be just more than 1. Lily or Izzy, what'd you get?
1.02.
All right, but to 2 sig figs, we're probably just going to have to say about 1 mole. So the same pile contains almost 5 times as many bits of carbon as it does of iron. All right, if I have, 57 tons of horses versus 57 tons of elephants, I've got a different number of those animals in there. Let's draw this diagram in our notes. Okay, I think we did the top of this diagram in days past. We're going to do this diagram. This diagram is going to be pretty key. We're going to give this like a half a page, okay? Or at least a third of a page. It doesn't have to be a whole half page, but you should give it some space. Have some vertical lines between things. Write number, volume, moles, and mass, okay? And spread them out a little bit. That'll work.
So where will we be writing stuff just like
Right on the branches in between. Okay, so if let's go from moles to volume. If I know how many moles I have and I wonder how much space it's going to take up, what do I do?
multiply by 22.4.
Right on. Multiply by 22.4 liters per mole. Somebody raise their hand and tell me another thing that we know on this diagram.
If we come into moles, so we need to divide
From where?
from volume to mole.
From volume to moles. From coming from volume into moles, I divide by 22.4. How much stuff is in this balloon? Divide by 22.4. Okay. If I want to go from moles out to number of atoms or molecules, what do I do? Amen. Multiply by 6.02 times 10 to the 23rd. Okay. If I want to go from number of bits into moles, what do I do? By
6.02 times 10
right on 6.02 times 10 to the 23rd. Okay. Now here's our new one, and this is why we save this one for its own day. Right?
Grams per mole.
Yeah, it's the grams per mole. So if I'm going from moles out, I'm going to multiply by the grams per mole for the periodic table.
Times atomic mass.
Yep. If I'm going from mass, from grams, from how much something weighs in, I'm going to divide by the grams per mole from the periodic table. So what's tricky about this bottom leg is it changes every time. Okay? It changes for whichever chemical you are doing. You're going to have to look up the weight from the periodic table and put that in there. That's the number you need.
So
These top two legs are always either 6.02 or 22.4.
in
How
case
would you
anyone is
Trent, I
forgetting,
called on someone who raised their hand. Please go ahead.
How would you go from mass to moles if it wasn't like a single element? Like what
Great.
was, like, a molecule?
Great question. What if it was CO2? What if it was carbon dioxide? How much would a mole of that weigh? Well, we should have to look at what's in this molecule. Okay, that molecule is made of 1 carbon and 2 oxygens. So I'm going to do 1 times carbon plus 2 times whatever oxygen is. Okay, let's do this together. Write down CO2. Okay, 1 times, what does carbon weigh? 12.01. Plus 2 times what oxygen weighs? 16.00. Okay, 1 times 12 is 12. 2 times 16 is 32. 32 plus 12 is?
Plus?
40,
Yep. Nope.
44?
44.
Yes.
Okay. So when you're looking at each element, it's multiplied, but then you add up those 2 chunks together. So 1 mole weighs 44 grams. Okay. 2 moles would weigh 88 grams. 2.63 moles would weigh, calculators,
So you do 0.63 times
2.63 times 88 gets us,
2.63 times 44.
oh, 2.63 times 44, my bad. Gets us
16.
okay, I've got 3 sig figs, so I'm going to stick at 116 or I round it up.
Say that.
Well, 116 is good because I rounded to 150.
So 116 grams. Smile and nod. Okay, so we have to add up. We'll do another one of these. We're going to add up the bits that are in the chemical. Okay, salt, NaCl. Give me a number. Somebody tell me the number of grams. Make it up.
12.
12. Okay, we have a pile of salt that weighs 12. I'll make it interesting and say 5 grams. 12.5 grams of salt. How many moles are in that pile? Go. And talk to the person next to you. You gotta just put these things together.
How do you?
Easy. Say those question for you. And
So you're going. Yeah, but you don't know what it is. Oh, true.
we have 12.5 grams. I want to go into moles. So I want to divide by the grams per mole. I have to figure out what the grams per mole of this compound is. This compound is made of a sodium. How much does sodium weigh? 22.98. How much does each chlorine weigh?
33.45.
33.45. Okay, if I put those 2 things together, I get what? 58.44 grams for each mole. Smile and nod, yeah, okay. So 12.5 grams divided by 58.4 grams per mole gives me, should be less than 1 mole, should be like, 0.214 moles. So you look at each element that's in there, and if there's just one of them, you just put those 2 things together. Alright, let's do another one. Alright, here are some crystals of aluminum oxide. Okay, we want to know how many moles are in there, but first let me answer the question.
Do we have to round to 6 figs while we're doing
Yeah, we keep track of these because these are our original measured quantities, so we do keep track of our sig figs a little bit. Yep.
So you get 2 of the AL number.
Yep.
3 of the O number.
Oh yeah.
Add it all.
Uh-huh.
And then divide.
Yep.
Okay.
Game on.
This is like
This is your laptop. Do you have the schedule for that?
It is the normal schedule. I forget how much time is in each one. I don't have one in the room.
So it's just the classes are shorter.
Yeah. Okay, 2 times what aluminum weighs, plus 3 times what oxygen weighs. 2 times 27 is like 54, so this is going to be 53.96. 3 times that is 48.00. If I add these together, I'm going to get just over 100. It's going to be 101.96 grams for each mole of this stuff. So if I have 17.8 grams and I divide it by 101.96 grams per mole, I am going to get 0.175 moles. Oakley dokley? Okay, so one obvious opportunity that we have now that we're